So let's compute some probabilities where we roll a pair of dice. Supposing that we roll a pair of dice, and so up here is our sample space for rolling a pair of dice. Let's find the probability of getting a sum of 5. Well, I know I'm going to do some division. I need to have the total number of outcomes on the bottom, and so we know that that's 36. And then up here I need the number of ways to get a 5. So let's figure out how many ways can we roll a 5. Well, we could have a 1 and a 4, or a 4 and a 1. We could have a 2 and a 3, or a 3 and a 2. And those are the only outcomes that will add up to 5. So that's a total of 4 possible outcomes out of the 36. And we can reduce this fraction to give us 1/9. Now you can express probabilities as fractions, and often when they're theoretical probabilities, you'll probably notice that I will leave my answers as reduced fractions most of the time, but it's also perfectly acceptable to actually do the division on the calculator when at 1 divided by 9, 0.11111 repeating, so we could round that to the nearest hundredth. So we could express it as a decimal or also as a percentage. So probabilities can be expressed as any one of these three options. I would go at least to the hundredths place. I think probably more often than not you'll even see me go to a thousandths place, so the 1/10 of a percent. For theoretical probabilities, I usually leave them in this exact sort of reduced fraction form, just because that way I don't have to round anything. In part B, let's find the probability of getting a sum that is less than 5. So a sum less than 5. So I need the number of ways to get that sum less than 5, and then divide by the size of my sample space, which is again 36. So if I got a sum less than 5, that means I either rolled a 2, a 3, or a 4. Right? We can't roll a sum of 1 because the lowest we can get is double ones, which is a 2. So there's only one way to roll a 2. You have to get those double ones, and there's only one way to get each set of doubles. So on to getting a sum of 3. I've got to get a 1 and a 2, or a 2 and a 1. And that's the only way to get a sum of 3. And then for a sum of 4, I can get a 1 and a 3, or a 3 and a 1. But I could also get double 2s, right? Only one way to get double 2s. And so counting all of these up, find that there are 6 ways total. And so there's my numerator. 6 out of 36, which we could reduce to 1 out of 6. The probability of getting a sum less than 5 is 1 out of 6, which is approximately 0.16666 repeating, so 0.167 say, or 16.7%.